Welcome.
All right, so thank you everyone also from my side. My name is Martin Halle, and what I'm going to talk about is actually the topic of research questions that we have raised, and especially that could lead to publications of the Aerospace Working Group within the ELISA context. So, brief introduction to me. I'm Martin Halle from Hamburg University of Technology here in Germany, actually. I'm the Aero Working Group Co-Chair, and with me is Matthew Weber from Boeing Company, and he is the Aero Working Group Chair. So he will cover up the chat in case you have questions. And what I will talk about is basically you know that in aerospace we have quite a few regulations, so it is actually quite challenging, but still interesting to introduce Linux into aerospace. And we are, although the group is called Aerospace, we are not only aerospace folks, but actually also space folks. And because of this, we found out quite a few questions that are raised that should actually be more in-depth, be researched, and then being contributed also to the community. So essentially what we are looking for is really serious contributors and experts that would like to help us to come up with publications in the end. And this is what I'm talking about today. And for those who don't know the Aerospace Working Group, I put on the link on a GitHub, on the ELISA tag, there's also the Aerospace Working Group in the end. So without further ado, what are our thoughts on these? So first of all, we identified that actually even addressing the question, where is usually Linux used in aerospace, is not so easy to do, at least not in aerospace, because of the specific needs. So usually there is not much where you use Linux. Usually this is very restricted nature, because you have proprietary operating systems, proprietary hardware, which needs to be also certified and so on and so forth. And one of the ideas we had is, okay, we have covered quite a few examples of where it is actually used already in aerospace. And we tend to write a survey paper here that would cover the question, where is Linux already used in aerospace? And what we did is we made up on the ELISA homepage, we made up basically kind of a discussion where you can vote. So if you are interested and you can contribute to this question, where for now is Linux used in aerospace, maybe even on safety critical systems, then please go to that place, and basically you just need to vote and say, okay, I'm interested in that one. And what we will then do is we will team up and form a team that would address only this. We have a once in a month session where we cover only paperwork, so only addressing scientific paperwork. So this would be organized in a way that we would invite you to those sessions to work on that topic. Now, as I mentioned, there's Linux for aerospace is quite difficult. Actually, our space guys are actually a little bit different, because here it is not the same, but sometimes quite close, but sometimes also more open. So the second survey paper that we envision is actually do the very same, but just in space, because space is usually a more open source nature, and you may find way easier access to actually use Linux, and even with less restrictions in that domain. Now, there is a difference between manned and unmanned. This is what we found out, and space is also more mission-driven, maybe. But still, it would be a nice survey paper to actually invest into, to discuss, okay, what is the state of the art of using Linux in space? So if you are a space guy or you know more about it, please step up and vote for that idea under the link given. Now, given these two, of course, the actual interesting questions that we have raised, and we tried in the first place to cover that in one paper, but then found out is way too much, is actually to put the first two papers together. So therefore, there's an order, and then compare those two usage domains with respect to what they actually need, hardware-wise, software-wise, operating system-wise, if there is still regulation to be considered, and what's the exact regulation is, and is it different, or can it be shared between space and aerospace? Do we need certification for some of the parts, for the system functions, for example, and really make this a comparison in the end, which would be the final outcome of the first two papers in the end. If you're interested in that one, of course, this is postponed, obviously, because first we need to make sure that we understand space and aerospace needs as a whole. But if you're interested in that one, you can also vote here. Now, the next question is actually goes more into depths of the regulation. So regulation, we already found out, is quite a huge part, which already hinders us from looking into safety critical domains at a higher level of regulation, so at a higher safety criticality level. For those of you who are aware with DAL standards, so design assurance levels, what we talk here about is DAL A and DAL B maybe. So if you want to go that way, then actually the question would be, and this is what we found out, what are the actual regulation needs and the desired effects on Linux as an operating system or as a platform in space and aerospace? So what does it cover? What does it not cover? And what would be needed? And also here we see clearly a distinction between space and aerospace because regulations are different. So here it would be quite interesting to also see would regulation have an effect on Linux, or can we work around it? Or what would be the actual way to go if you want to make it practical, actually? And even could we achieve a common platform for both domains, meaning space and aerospace? So if you're interested in that one, there's the link. And if that sounds like a good idea to you, just please join. Then, why working in the working group? Actually, we had quite a great time in declaring what we actually mean and by what do we want to achieve. Is it an operating system? Is it part of the operating system? Is it also covered with hardware, without hardware needs? And to do so, we came up with, okay, let's first discuss what is a common use case that we can, that we understand, that we are all familiar with in the aerospace and space domain, and that we can use as an example to actually move forward in the end. And this is something where we already have a use case in place. So there will be a very nice talk held by Matt tomorrow at 16:45, talking about all of this. And this shall show the capabilities that you can actually achieve for Linux and aerospace, really practical on a practical use case. So what are software concepts? What are maybe hardware concepts? What are considerations with respect to regulations? And what are the tools and methods you would need maybe because of regulation, or you would pick because they are available and they are nice to use? So what development platform? How would you achieve VNV, verification and validation, because that's always a requirement in space and aerospace, and so on and so forth. So if that is of interest to you, listen to the talk of Matt first of all, and then you may want to join also that idea. And basically, while doing this, and again, there's a reminder, you should really listen to the talk of Matt. We found out quite nice ways to actually come together in space and aerospace and come up with a platform, a development platform that we were defining and developing to make use of this at the whole aerospace working group level. So we see actually this also as a paper to explain or to, basically open up our experiences that we had with setting this up. So basically an open platform, what software stack we have used. So we're using tools from NASA like Copilot and Ogma that are very helpful if you want to focus not so much on the application and testing and validation, because this is basically covered, but more on, okay, what is the effect on the Linux environment, for example. Then we have actually several integration stacks, so we allow this to be run on a native platform or a container-based environment. And setting this up is actually quite easy. So we have a CI/CD pipeline in the meantime, where you could actually easily participate by changing some of the functions to your needs, and basically just let the automation run and see what is the effect on a software level. And then basically we did this so that we can share it. So it shall be, and it is actually an open shared development environment that everybody can use. And even here, we found out ways how to do this and how to cover the different needs and different aspects. And I think this is worth sharing. So this can for sure be kind of a white paper or even a scientific publication. So if this is of interest to you, maybe, of course, you should join also our use case group in that case so that you know about this. But if you're interested in also providing help here, please step forward and vote on the link given. And basically to summarize, so this is my last slide for today, is what we found out, we really need people to move forward and to move on. And even if we have a lot of experts on board already, usually time is limited. And since we are space and aerospace, sometimes we need really to have the right experts on board to move forward. So this is what we are seeking here. So we are looking for people that want to actually seriously contribute. So within the time frame given, once a month, preparing content, discussing content, and really just write the paper in the end. Of course, it's very helpful if you're an expert in that topic, because we really look for people that can tell us what are references, for example, in aerospace that we are not aware of, maybe. And as I mentioned, it's not a part-time job, so we really also look ideally for people that can join once a month or maybe once every 2 months or so, that we can actually really also come up with content. By voting on the platform, this will help us a lot to prioritize the topics and then form the expert teams that could then later on actually really do the actual work. So I, for myself, for sure will take part in quite some of the papers, but as an example from my side, I'm an aerospace guy, so I don't have so much experience in space, so here I would really need help. And as I mentioned, paper contributions, to make it concrete, will take place once a month. And we do have, of course, a distributed environment, so don't worry about tools and everything. So we can set up yourself easily that you can actually really contribute through Overleaf or GitHub, so that there's no technical hurdle in the end. And with that, I thank you very much. I left the licensing topic here because I didn't know if it's required, so I left it here, but I've finished. So thank you very much. Please contribute, and I'm open and happy about the question to answer any questions now. Are there any questions?
Any questions in the room? Any aerospace people? I'm not seeing any hands raised here in the room, Martin. Anyone online?
Right. So I think Matt put a few items also in the chat. So for the use case number 6, for example, so the paper idea number 6, we have a weekly use case demo group. So there you should join, and you actually can really see how the use case moves forward and what we have achieved already. And the next paper session is actually November 27th. So if you want to just sneak in and look at how this is going on without taking any serious decision already, you can please just join, and there is the registration link that Matt put on the chat.
We've got a question. Should we limit our votes to a single paper or multiple ones?
Yeah. So of course, if you have enough resources, you can also vote for several papers. Of course, yes, clearly. So because we are looking for experts, and maybe you're an expert in both space and aerospace, then please vote on both. So this will help us definitely. So not only a single one, you can concentrate on a single one. Just if you vote for 2 papers, you may have also more time to invest in the end, right? But we are very happy if you vote for more than 1 paper, of course.
Great. Okay. I will stop recording. Thank you.
Thank you very much.